Hello everyone, welcome to Chemical Bonding YouTube channel. Today we are going to discuss about two important sulfur compounds from main group chemistry, that is from group 16. So these compounds are called as oxoacids of sulfur. So we will be discuss about two oxoacids of sulfur. One is dithionous acid and the second one is dithionic acid. Dithionous acid is also known as hyposulfurous acid or hydrosulfurous acid. On the other hand, dithionic acid is also known as hypodisulfuric acid. So these two oxoacids of sulfur are very important regarding the competitive exam like CSIR-NET, GATE and IIT-JAM, etc. So we will concentrate only their structural properties and we will find some comparison between these two acids, some similarities and some differences. So this is the structure of dithionous acid and this is the structure of dithionic acid. So the name dithionous, one is dithionous acid and the other is dithionic acid. So if you want to comparison between some structural properties of between these two acids, so you find two two or three similarities and one or two differences. So first we'll find some similarities. We'll try to find some similarities. So let's focus on the structure. This is dithionous acid. This is dithionic acid. So both the acids have SS bond, SS single bond. Both the acids have two free OH group. Means they are dibasic acids. From this structure, you can easily calculate the oxidation state of each sulfur atom. So here the oxidation state of each sulfur atom is +3, whereas in the case of dithionic acids, the oxidation state of each sulfur atom is +5. Another major differences is in dithionous acid, each sulfur atom contain one lone pair. So here total two lone pair of electron presents, but in case of dithionic acids, there is no lone pair of electrons at all. So next we will be discuss about polythionic acid. So this is the general structure of polythionic acids. This N, the minimum value of N is 1. So when N is 1, then this acid is called as trithionic acids. When N is 2, it is tetrathionic acids. So there is some similarities between this, the name, similarity between the name polythionic acids, dithionic acids. Polythionic acids means trithionic acid, tetrathionic acids, and dithionic acids. So though there are similarities in the name Between what? Between dithionic acids and polythionic acids. So, but still, dithionic acids should not fall into the category of polythionic acids. So why? So in this case, there should be at least one sulfur atom between this sulfonic acid group. But see, in the case of dithionic acids, there is no sulfur atom present in between this sulfonic acid group. So the minimum criteria to fall into polythionic acid category, the N value should be more than should the N value, the minimum value of N is 1. But in case of dithionic acids, this N value is 0, means this middle sulfur was not present. So we can say that polythionic acid, we can say that dithionic acid should not fall into the category of polythionic acids. Now we will see the anionic species of the previous two acids. This is the acid, dithionous acid. This is the dithionic acids. Now we will see the anionic species. When we remove two A's from these acids, when we remove two A's from these acids, one dianionic species is formed, and when we remove these two A's from this dithionic acid, another dianionic species is formed. So we will discuss about the dianionic species now. So when we remove two hydrogen atoms from dithionous acid, we got dithionite. It is also known as hydrosulfite. So dithionite is a dianion of dithionous acid, or you can say conjugate base of dithionous acid. The structural properties are same as in case of dithionous acid. The oxidation state of each sulfur atom is +3. Each sulfur atom contain one non-pair electron. There is presence single SS bond. So this dithionite is a dianionic species. So let's see the other one. So when we remove two hydrogen from dithionic acids, we will get this dianionic species. This is called as dithionate, or you can also call it conjugate base of dithionic acids. It is also known as metabisulfate. So the structural properties are same as in the case of dithionic acids. So each sulfur atom is in +5 oxidation state. There are single SS bond. So uh, and there is no lone pair of electron present on sulfur atom. So the structural features, so the comparison between the structural features between the dithionous acid and dithionic acid are applicable in the case of the dianionic species also, that is dithionate or dithionite. Just we have to remember that name, dithionite dianion came from dithionous acid, dithionate dianion came from dithionic acid. So here are the some comparison, some similarities and some differences. As we discussed previously in the case of the acids, so these are the conjugate base or dianion of those acids. Dithionite, conjugate base of dithionous acid. Dithionate, conjugate base of dithionic acid. So both are dianionic, both have single SS bond. Oxidation state of each sulfur atom in case of dithionite is +3. In case of dithionate, it's +5. sulfur atom in dithionite contain on lone pair electron, whereas there is no lone pair of electron on sulfur atom in case of dithionate. So now here I want to mention one point, important point, that regarding this dithionite anion. So usually this SS bond is quite longer than expected. It is quite longer than normal SS single bond. So that's why this dithionite anion is so unstable and it easily break into two radical anion via homolytic cleavage. So this is the homolytic cleavage and it's break into two radical anion. So the reason behind the extreme instability of dithionite anion is, so we all know the Benz rule. From Benz rule says that if there are different substituent with different electronegativity connected with a central atom, then the most electronegative substituent prefer the hybrid orbital of the central atom that has more p character or less s character, and the less electronegative substituent prefer the hybrid orbital of the central atom that is more s character. So if you consider this sulfur atom as a central atom, there are two oxygen atom and one sulfur atom connected with this sulfur atom. So the hybrid orbital of this sulfur atom directed towards this oxygen and also this oxygen have less s character, and so we can say the hybrid orbital of this sulfur atom directed towards this sulfur atom have greater s character. So as a result, this bond become short and these two sulfur atom come close to each other. Under this condition, when they come close to each other, they are create a extensive lone pair repulsion between these two lone pair. So to release this lone pair repulsion, these two sulfur prefer to stay far from each other. That's why this sulfur-sulfur bond become very long and weak also, and hence it easily break into radical anion via homolytic cleavage. So I am repeating it again. From Bain's rule, we can say the results of Bain's rule is what? In this case, Bain's rule says that these bonds between this SS bond become shorter according to Bain's rule. When these bonds become shorter and this sulfur atom come close to each other, in that case, under this condition, the lone pair repulsion become very extensive. And to release this lone pair repulsion, these two sulfur atom prefer to far away from each other, prefer to stay far away from each other. That is the main reason. Uh, that is the main reason behind the uh, abnormal abnormality of the this SS single bond. Abnormality means this SS bond is quite longer than expected. So same thing is happen in the case of dithionate, but in this case the tendency is somewhat less. It will break into the radical anion by homolytic cleavage, but in this case the tendency is less because there is no lone pair present directly on the sulfur atom. Obviously, there are three oxygen atom and oxygen atom contain lone pair, so there happen some lone pair repulsion between this oxygen and this oxygen lone pair, but since there is no direct lone pair in sulfur atom, that's why the lone pair repulsion is not so much extensive. So that's why it is quite stable, and uh, so it's quite stable. It is less unstable than, we can say it is less unstable than the that dithionite anion. So I think you all you all understand that point regarding the Baines rule and why we got the longer SS bond than expected. So I picked up on question from CSIR-NET 2019 December. So it's from part C, 4 marks question. So it's from the dynamic species. So the correct statements for dithionite and dithionate anions from the following are, so dithionite and dithionate means these are not the acids, these are the dianionic species of the acids. Mean this dithionite is the dianion or conjugate base of which acid? It is dithionous acids. And this dithionate, it is the conjugate base of which acid? Dithionic acids. So we have to remember this thing: dithionous acid, dithionite, dithionic acid, dithionate, dithionous acid, and dithionite. Sulfur atom is in +3 oxidation state. Sulfur atom contain lone pair, and in both case, both the dianionic species, there are sulfur-sulfur bond. So in the question, which are correct? The options. So A option says both have SS bond, that is correct. B, both are dianionic, that is also correct. C said oxidation state of sulfur is +3 and +5 respectively, means dithionite and dithionate. So +3 for dithionite, +5 for dithionate respectively. It's also correct. So if it is says like dithionate and dithionite, then it is reverse, +5 and +3. So dithionite and dithionous, same, sulfur atom is in +3 oxidation state. Dithionate and dithionic acid, sulfur atom is in +5 oxidation state. It's also correct. And sulfur in dithionate has lone pair of electrons. So let's see. Dithionate means the dianionic species of dithionic acids, and we all know that this dithionate and dithionic acids, there is no lone pair of electron on sulfur atom. So you have to remember the structure and name also. So they say that sulfur in dithionate has lone pair of electron. So it is wrong answer. If they uh, say it like that, sulfur in dithionite has lone pair of electrons, then it is also correct. But they said that dithionate. So dithionate or dithionic acids in sulfur atom, there is no lone pair of electron. So only A, B, C options are correct. So the option A is correct. So that's all for today. Thank you for watching. Stay safe, stay healthy.